Okay, so in this video, it'll be on pretty much momentum and inelastic collisions. So our first question is a 10.5 kilogram cart moves right with a 5.00 meters per second velocity and collides with a 2.0 kilogram cart moving at 1.0 meters per second, and the collision happens inelastically. So the first question asks, what is the common final velocity? So we can use the equation m1 v1 naught plus m2 v2 naught equals m1 v1 final plus m2 v2 final. But we notice here that since it's inelastic, the final velocities are the same, because inelastic means they come together at the end. They stick together. The masses stick together. So that means they have the same VF. So what we can do is change this to where it's VF and it distributes out into M1 plus M2 and equals the same. So let's plug it in. So our M1 is 10.5 times V1, which is 5.00, plus M2, which is 2.0, times V2, which is 1.0, equals VF, which is the variable, times M1, which is 10.5, plus M2, which is 2.0. And we can plug this in to get our VF as 4.4 meters per second. Sig figs, whatever, it doesn't really matter. So that is how to find the final velocity. Now, the next question asks, what is the change in momentum of the 10.5 kilogram cart? So what is delta P, change in momentum? Well, change in momentum equals m times delta, change in velocity. So because the mass isn't changing here, it's the velocity that's changing because the mass is staying the same for the 10.5 kilogram cart. So the mass isn't changing, velocity is changing. So we can find VF and subtract it from the initial. So delta P equals 10.5 times our final velocity minus initial, which is 4.4, minus initial, which is 5.0. And our delta P comes out to 10.5 times 4.4 minus 5. Our delta P comes out to negative 6.3. And the units for this are kilograms times meters per second, because it's mass times velocity, which is meters per second. So that is how to do number 2, which is the change in momentum. And now the final question asks, if the collision lasts 0.020 seconds, what is the average force on the 10.5 kilogram cart? So, well, we know the change in momentum, and we know the equation delta P equals force times the change in time. So these two equations are pretty much the same, and we know two things here. We know the time and we know the change in momentum. So we can just algebra solve. So negative 6.3 equals force times the change in time, or just time here, which is given, which is 0.020. So then divide both sides, right, and we get negative 6.3 divided 0.02, and the force acting on it is equal to negative 0.126 newtons. And that is how to do a question like that. Okay, our next question asks, a 1.20 kilogram cart moves right at 5 meters per second, and it collides with a stationary 0.8 kilogram cart, and the collision is inelastic, so they stick together. After the collision, there's a constant opposite, or in other words, left, force of 6 newtons for 0.40 seconds. So the first question asks, what is the VF after the collision? So as we know, we can use this equation up here. So what is our M1? M1 is 1.20, V1 is 5.0, and let's think about this. Stationary would mean the velocity is 0, so 0 times the mass would just become 0, so we can cancel out, and this just becomes equal to m1, which is 1.20, plus 0.8 times VF. And let's solve for VF here. And we get VF equals 3.0 meters per second. So that is how to do the first one. The second one asks the impulse of 6 newtons. That is which is the force being applied. So what do we do here? Well, the impulse, or I saw somewhere you could use J as the units for impulse. So J equals 6, right, times, and it's 0.4 because it's force times change in time, right? It's this equation up here. However, the force is going in the opposite direction, and direction matters here. So the force here will be negative since it's going left. So the impulse is going to equal negative 6 times 0.4, which is negative 2.4 kilograms times meters per second. Boom, that is how to do that one. Now, the last one asks, what is the VF after the force is applied? So here we, once these collide, they join, right? They stick together, so this is what it looks like when they collide. It's 1.2 and 0.8. So these masses together are going to equal a total mass of 2.0 kilograms, right? And then from here, we can use the impulse, or J, equals mass times delta V here. So what are we solving for? Well, we know the J and we know the M, which is 2.0, and we have to find the delta V. So we can set up this to be negative 2.4 equals 2 times delta V as our variable. And we can get our delta V to equals negative 1.2 meters per second. That's just using simple algebra. And then from there, what is delta V? Delta V is final minus initial, and we pretty much know the initial, which was found right here, the VF. So it is delta V equals V final minus V initial. So negative 1.2 equals VF, our variable, minus 3.0. And we can come up to our VF equals 1.80 meters per second. And that is how to solve that one.